Okay, so here are the non-planar type graphs, or this is what we're going to get to. Can we connect the electricity and the gas to the four houses without any lines crossing over each other? And I think this one's going to be easy. I hope so, because I'll do it really, really quickly. There's my electricity going to all the four houses, and here is my gas going to all the four houses. And it's not very efficient, and it's probably not the way they do it in real life. But what we've done is we've connected the gas to all four houses and the electricity to all four houses without them crossing over. Because we can do it without them crossing over, that's what's called a planar graph. We can draw it on a plane being a two-dimensional sheet of paper, really, in this case. Can we do it with five houses and three? And pretty much the same technique. We can draw all the electricity like this, and then the gas can go here, here, here. And pretty much we've done it again. We've connected the five houses to the gas and the five houses to the electricity without them crossing over. A planar graph. Let's suppose we've only got three houses now, but we've got electricity, gas, and phone. Can we connect these? And what you find is that I can do the electricity to three. I can do the gas to three by going around this way. And I can maybe do the gas to that one like this. Okay. All good so far. Can I get the phone to two? I can get the phone to there. I can get the phone to that one. But I actually can't get the phone now to this last one because I've cut it off with these two lines and I've cut it off here. This is what's called, and then I have to do this sort of dotted line, which isn't what the task was. The task was don't cross over. This is a non-planar graph. So before it was a planar because we could do this. As soon as you can't do that, it becomes a non-planar graph. They get to non-planar graphs quickly. If we've got four, sometimes they're hard to do, but if we've got 4 points, we could set it up like this. Can we draw a non-planar graph? And we have to connect every point to every other point. There's a non-planar graph. If we set it up like this, it's probably even easier. A non-planar graph. These are the same graphs, really. Here, if we set this to be A, it's connected to B, C, and D. If we let this be A, it's connected to B, C, and D. This is connected to every single one. This is connected to every single one. These are the same two graphs. They are just what we call an isomorphic picture. Exactly the same graph, just a different picture. So if we look at the four examples that we've got from this sheet that I asked, which ones of these are planar graphs? Well, train lines, that's a network. That's the Sydney network. That is a planar graph, all on one dimension there, or two dimensions, just laying flat on a sheet of paper. This situation here with the roads, that to me looks as if it is a planar graph. There's no bridges, there's no crossing over. You can just everything's on the one dimension, on this two, it's flat to the ground. As soon as we get to this, though, if I can just scroll up, this is not planar. If we look at it, all these lines are crossing over like the dotted line in the three houses to the gas, electricity, and the phone lines. This airport, or the air, that's different to the trains. The trains was a flat. The roads were a flat. But this, there's all these crossovers. So this is a non-planar network because there's this line here is crossing over. This line is crossing over. Lots of lines are crossing over. No matter how we fly, we have that crossover event occurring. That is very different to this situation where there's no crossovers. Very different to the train situation, planar graph, no crossovers. There's lots of those edges crossing over. Hope that helps a little bit. Thanks.